Hi, my name is Doug Lucas, and we're coming to you tonight from the outskirts of Louisville, Kentucky. We call this channel Emerald Hill Skies because our RASA 11 is based in this Telestation 2 roll-off roof observatory. That's an 11-inch Celestron RASA with an ASI 2600 MC Pro camera on the end. Tonight's live stream is a little bit different than most. We're viewing one particular object tonight, M101, the Pinwheel Galaxy. And as such, we call this kind of live stream a SkyPortrait. And we'd like to invite you to come along with us, whether you're tuning in live just because you happen to catch us impromptu here, or whether you're watching this as a recording. Much more likely, since we're recording this at midnight, in the middle of the night. Tonight, what we're going to try to use is this 11-inch telescope, and that's a live view of the scope on the left there. Viewing this sky, you can see the Big Dipper or Ursa Major right there in the middle of that night sky. This is through our ASI 178 monochrome camera with that, which actually rides on top of the RASA. And that night sky view is just, to me, just beautiful. Really clear and black tonight. A little bit of a moon beginning to sneak in, but it's not really bothering us that much. Tonight, what we want to try to view, like I say, is this object, M101. Now, to find M101, you could use a pair of binoculars in a dark sky and look for the Big Dipper. Remember our view of the Big Dipper here. Look for the Big Dipper and find the two end stars of the handle in the direction of the open bowl of the Dipper. And notice how that M101, they're located where those crosshairs are. M101 makes an equilateral triangle, all three sides the same roughly, with Mizar and Alkaid, the last two stars of the Big Dipper asterism, Ursa Major constellation. Now, to orient yourself, this would be looking due north. This is the meridian line here. Then go a little bit east, so northeast, up about 45 degrees tonight as we make this video. And this is one of the most beautiful galaxies that we can see. You'll need binoculars to see it, most likely. It might be naked eye in the darkest and darkest of skies, but better yet, with binoculars, you can see it. What's really interesting about M101, or the NGC number would be NGC 5457, is that it actually, as an NGC or a new general catalog object, it actually contains 10 other NGC objects within it. So if you add up the NGC designation for M101 as a whole, that's NGC 5457, and then all of the 10 NGC, they're all hydrogen alpha emission nebulae within NGC 5457. You actually get 11 NGC entries in one. Now, maybe you think, well, what's the big deal about that? It happens, that's the most of any object in the thousands of NGC catalog objects. It's the most that any one object has. So let's see if we can tune in tonight and look at these. First of all, you can just count the Pinwheel Galaxy NGC 5457 as one, and then look at NGC 5471. At first glance, it might look like NGC 5477, which is, by the way, a companion galaxy of the Pinwheel. But if you get a little bit closer look and look at the data of NGC 5471, you find out that it's actually not a galaxy like NGC 5477 is. It's a hydrogen alpha region within this very slight spin-off arm of M101. So that already counts as one. Now remember, don't count NGC 5477. Starting with NGC 5471, then you go down this arm, you get NGC 5462, 5461, 5458, 5453, 5455, 5451, 5449, 5447, and 5450. And if you add all those up, you'll find 10 NGC objects in the 11th NGC Galaxy. So that's a lot of NGC objects in one single galaxy. Like I say, more than any other. Let's see if we can look at it live. So now let's go. By the way, seeing the galaxy as a whole through binoculars is one of the challenges that Phil Harrington lists in his book, Cosmic Challenge. So it's one of the challenges. But then being able to see all these extra little hydrogen alpha regions, he calls that dissecting M101, and that's challenge 137, which is the one that we're working on tonight. And for that, you'll likely need a double-digit aperture telescope, something 10 inches and larger. And like I say, we have this RASA 11 tonight, an 11-inch scope. You'll need that size scope to see all of these other hydrogen alpha regions. So let's go to the live screen now. This is actually the live screen. Again, we're capturing M101 here through SharpCap. And this now kind of reveals to you the three major pieces of software that we consider to be the ideal for using with electronically assisted astronomy. That's what we consider this when we're viewing the object with a screen instead of an eyepiece. This RASA 11 doesn't even have a place for an eyepiece. There's not even a socket for it. The only way you can use the RASA 11 is through astrophotography or through EAA, which is what we're doing here. Now, while we've been setting up the video, setting up the live screen, getting everything arranged, making the thumbnail and arranging the title, we've had about 29 minutes tick off here. And that has let us see what M101 looks like with 29 minutes of integration. And we can tune this up with maybe some of these vertical sliders here and make it look exactly like we want it to look. A little more dark sky in the background by defining the dark sky to a different black level, again, using EAA principles. But here you can see the way the object starts to form up. Remember, don't count 54, what is this, 77, is that what it was? But do begin counting with 5471, which did look like an outlier in the beginning. But this is a companion galaxy, this is not. This is a hydrogen alpha region. You might wonder, well, how can you be sure? Well, in the old days, we would have to use sketches like Harrington's sketch here. But again, with EAA, we can use what's called deep sky image annotation. And it lets us see exactly what we're looking at here. And this clarifies for us. 5477 is down here. So this is 5471 here. That way we know exactly what we're looking at. 5471, 5462, 61, 57, 58, 53, 55, 51, 49, and 50. Now I've listed all these NGC objects in the description down below. But I also thought it might be interesting. This is 30 minutes, and you might say, well, you know, is that really EAA? So I thought, well, let's just clear, I'll save a copy of this photo exactly as seen, just so we do have the 31-minute version. But let's also be fair, and let's clear the decks. So now what we've just done is eliminated all that memory from SharpCap. So we're going to start from scratch. Let's suppose we just honed in on M101. This is the 22nd version that you're looking at here using electronically assisted astronomy. Now right away you'll notice a lot more of this, what you might call grain. Just little confetti looking noise out there in the sky. Remember where we had dark sky a while ago? Now notice how it just got better? That's because we added in the second 22nd image. And SharpCap already began to see, oh wait, the place where the confetti-like sparkly grain was, that wasn't really an image in the night sky. And how did SharpCap know that? SharpCap knew that because that part of the image was real tingly. It just sparkled and varied too much to be a star. It was like just changing pixels too fast. And SharpCap said, that's impossible. And in the averaging of these frames, we're up to 4 frames now, SharpCap is saying, okay, if it's a steady light in the same pixels, then that must mean that it's a real star or a deep sky object, and we're going to average those up. And if it's not, then we know it should have been darkness. So in other words, it's like moonlighty stuff, or maybe light pollution from the city of Louisville here, and we're going to average those down. And so our signal to noise ratio gets bigger and bigger and bigger. The signal gets better and the noise gets lower. So we're at 120 seconds now. So that's just 2 minutes. But already after 2 minutes, we can actually already begin making out all of these objects. So let's plate solve only so SharpCap has a fresh view of the night sky, and then use our deep sky image annotation. We're already seeing 5471. We can see 5462 clearly. 5461, 58 is that cloud right in the middle of those crosshairs. 53, again visible. 55, 51, 49, and 50. All of these NGC objects were visible after 2 minutes. And the night sky is actually not too bad at this point. It's already dark enough to differentiate between all of these objects. And if you wondered what these objects are, the magnitude, it's hard to say what they are. Here in, let me see if, turn off this for a second so I can see what we're looking at here. Each of these for magnitude comes in at 13 or 14. So these are 14th magnitude hydrogen alpha regions. And they all began showing up after just 2 minutes with this RASA 11. Pretty fast telescope, f2.2 ratio. But it does also, I think, make a strong case for EAA. You don't need 30 minutes of integration to be able to see all of this night sky object. All you need is just really 2 minutes, and you can already see all of what we've been looking at here tonight. So for you now, what does this let you do? Well, I hope what it lets you do is, first, in the night sky, you can begin realizing that God has made a lot of really cool objects up here for us to see. Second, you'll need a pretty fast telescope if you want to see these things in 3 minutes or less. We're up to 4 minutes now. You'll need a pretty fast telescope. But if your telescope is f6 or f5 or even f10, you might just be able to look at an object for, 10 minutes instead of 2 minutes to be able to see these. But with these particular hydrogen alpha regions, they're showing up very quickly. I think you're going to find them quickly as well. Makes a strong case for EAA, makes a strong case for an amazing night sky. I think this is one of the most amazing objects that we can see in our night sky because of the beauty of all these arms. Look at the structure of this amazing galaxy. Look at all of this structure, all these star-forming regions. And again, all that hydrogen that's in these arms, you're being able to see with these H2 regions. Those are the challenge for 137. It's what we're working on tonight in the SkyPortrait. Thank you for tuning in. If you like content like this, we hope you'll subscribe, maybe even hit the bell so you can be notified when we do content like this, and only if you prefer, only if you like. If you want to hit the thumbs up, then that'll let you help us get higher in the average of content like this in other people's searches in YouTube. But either way, I hope you'll come back for our normal live streams, which are usually much more interactive. We talk to the folks that are logged on, and I hope you'll come back for those. We've formed a kind of a community here, and Whether you're watching this one live or recorded, welcome, but we hope you'll come back for the live versions. If you want to know when we'll be doing these, you can go to emeraldhillskies.com. And there you'll find a quick little form, just a 10-second form. Put your email address and name in there, really just email address. And then you'll get an email notification, usually the night before we're going to do these kinds of live streams. We usually do 2 hours from the outskirts of Louisville. We hope that you'll join us. And that's it for tonight. God bless and have a good evening. Good night from Emerald Hill Skies. And thanks again to God for making all these cool objects. We'll see you next time, I hope. Take care. Good night.